Warm and delightful good morning to everyone present here. I welcome all the participants, delegates from different institutions to take time and to participate in this session. Today we have with us Dr. Nidhi Lal, VNIT Nagpur, Assistant Professor, CSE. So I welcome back you, ma'am. You may proceed with the session. Thank
Just the marker. Okay. So good morning, all of you. Good morning. So again, I'm going to introduce myself in a short description. My name is Dr. Nidhi Lal. I'm an assistant professor in VNIT Nagpur. So in the today section, we will cover about the advanced deep learning concept. The advanced deep learning is that one in which we have to provide some application level interfaces such that we can pursue some research over there, some applications over there, as well as we have to provide some connectivity between a user and applications in a broad level. In a broad level means we can drive our applications in a different area. Like you can apply the GAN in different domains, right? So GAN, generative adversarial network, GANs. You can see in the topic name, it is a three combination of words: generative, adversarial, and networks. So generator, from the generative name indicates it has to generate something, right? It has to generate something. In our basic deep learning and the neural networks, we are not generating something. We are just only predicting or classifying something, right? But here we are not predicting, we are generating something. But it does not mean that we are not predicting anything else. We are predicting someone, but in terms of the generator. The second term is adversarial. Adversarial means competition. In the competition perspective, these neural networks have to learn from each other in a competitive way. Like in our organization, we always say that healthy competition is needed to grow up in the career, right? What is a healthy competition? Healthy competition is we have to learn something from our competitors, okay? Not luck pulling. It is only learn something from our competitors such that we can grow in our path, right? So, like the same way this adversarial is going to work, there are two neural networks working in the GANs. Both these two neural networks have to learn from each other, okay? Now the networks means there is a connections. So obviously if there is a two neural network, there is a connection between these two, right? And these connection can be used to establish, to learn the features from each other. So that is called the generative adversarial network. Now regarding the contents to be covered in this session, first we will cover the theory perspective, lot of diagram and lot of questions we will discuss. Then we will cover the hands-on session. For the hands-on session, already the code is available because the code is very hard to write manually. So I will share the code. You have to just directly copy paste from your Google Colab or Jupyter notebook and run that simultaneously, such that you can visualize that what thing and what snappy of the code is going to work. Now the first one is introduction about GANs. Till now I have only tell you about the terms regarding the GAN, generative, adversarial and the network. But what about the GAN definition? What is the introduction of this GAN? Why the GAN is introduced in our deep learning module that we will going to see. Details about the GANs means architecture about the GANs. Components of the GANs, there are so many components inside my GAN network. First we have to create the model, then we have to maintain the connectivity, then we have to compile the model. So many components we have. Then domain areas of GANs. As I told you in the first few lines that we have to apply the applications of advanced deep neural networks in different domains such that your GAN can be applicable to different domains also, right? So we will see such type of domains also. Then types of GANs. As you can see, our basic neural network is of different type: ANN, CNN, DNN, right? Also the CNN can be categorized into different parts according to my data set, VGNet, so many things, ConsNet. Then detailed architectures of the GANs. In the detailed architecture, we will basically follow some prototype of this GAN, that how can we implement our GAN in our real world environment, that we will to see about the coding perspective point of view. Architecture is only discussed in this two for the theoretical way, but for the coding view, we have to discuss this one, detailed architecture of the GANs. Now the last one is the hands-on. So hands-on, we will do some coding, some practical implementation. So just before proceeding to the theory, there is a one question for you guys. These are the two pictures, right? Now you tell me which one is the real one and which one is the fake one. Second is AI generated. So if you see any beautiful lady in front of you, so you always say that it is AI generated. That you want to say? क्या दिख रहा है? Your answer is right. Just I'm delivering the joke. Nothing personal. So yes, your answer is right that this one is the fake one and this one is the original one. Okay. So that is the today's topic, that we have to generate some fake images by our GANs network. So we already know about the controversy going on regarding Rashmika, South Indian heroine, as well as the Alia Bhatt, right? Some GAN related images, some abduction has to be do their pictures and video synthesis, and some video clips is going to viral over there. So that is nothing but the example of GANs. So this is only simple example. Another example is emojis, right? We are generating the emojis of our self image also, right? So these are nothing but GAN created images. So why this is one is the original and this one is the fake? As she is saying, right, that something edge is different over there. You can see the edge is sharp over there, right? And the pixel quality is high, as well as you can see the eyes contact over this thing and this one. Totally different. So we can say that our GAN can be used to generate the fake images. Generative adversarial network. So generative means generating fake images. Adversarial means it has to make a challenge to our second model. Okay. And network means there is a connection between these two images. Right. Now another example is saying when there is a red color over there, these are the GAN images, and when there is a green color circled over there, it is a real image. So many times we can see the red one colors is the fake one and the green one colors is the real one, right? So that is the beauty of the GAN actually. It generates the image in such a beautiful way that you cannot recognize that it is a fake one or it is a real one. Okay. So in the today's session, we will talk about only this generation of the images. How will you derive these images? Now introduction. Introduction is, it is launched in 2014 by the researcher Goodfellow and its teammates. Okay. Second point is GAN is basically an approach to generative modeling. As I told you in my previous session, what is the model? Modeling means automation, right? Generative modeling means we have to automate, generate fake images. But to do the things automatic, we need this training data. First, our model need to be trained with some training data. So at the initial perspective, we need some training data. From this training data, my generative model will learn the features. Okay. After learning the features, it is able to do the generate its own images such that it will look like the real images. GAN have two main blocks, two neural networks which compete with each other. As I told you, there are two neural networks, generator and discriminator. So those two neural networks are basically compete with each other. Competition. Now are able to capture, copy and analyze the variation. What the generator will do? Generator will have to learn the features from the discriminator by capture the features, copy the features as it is, as well as analyze the variations. Analyze means we have to learn from our previous loss variations. That is called the cross entropy method. It will utilize that we will see. The two models are usually called generator and discriminator. So this is our generator and discriminator, G and D I am abbreviated. Now, generative adversarial networks. These three terms I already depicted you, right? The generator means generate something, generate fake images. But how? In terms of probabilistic model. Naive Bayes is one of the machine learning tool, right? Based on the Bayes theorem. Okay, probabilistic model. Again, your generative model is based on the probabilistic. Probabilistic means joint probability we have to conclude. Joint probability means whatever the discriminator derive losses, it will combine the losses in two ways. The first one is the real one and second one is the fake one. Now, what is the probability of that particular image is to be a real, suppose 0.9, and what is the probability that particular image is fake, suppose 0.2. So, instead of making the loss in 0 and 1, it provides you the numerical value between 0 and 1. Like 0.9, 0.2, it will combine over there and something 1.1 will come into account and it will go again to the generator and it will train itself. Yes. It is not visible properly. So probabilistic model we have to use over there. Now adversarial, the training of the model is done is adversarial way. Adversarial way means these two are in competition, right? Healthy competition means these two are learning from each other, right? Now what D will do? D is a basic neural network. Basic neural network. The only task of this discriminator that it can provide the output in terms of real or fake along with the probability. So this is nothing but the label. 1 means real and 0 means fake. Once it is fake, the loss will get higher over there. Once the loss is higher, it will append to their back propagation. Once the back propagation is there, it will again train itself and try to improve by learning more features, analyze, copy and creation. Again, it has to provide some sample image, feed it towards the discriminator. Now the discriminator will again predict the things in terms of real and fake. So just like they are in the competition, in which my discriminator has to predict the correct things and the generator wants to fool the discriminator. And this phenomena is going on till my generator is successful to become a discriminator to be a fool, such that a sample created by the discriminator is fed towards the discriminator, right? And discriminator will now labeled as a real. So that is our main overall aim of this generative adversarial networks. Now first what the generator network will do, generator network takes random input in terms of noise. So there can be many multiple ways in order to provide the noise in the image processing, you know, right? some Gaussian noise you can append. So here typically noise we are using. So first sample will is nothing but noise only. It is an image having some noise. Generate samples such as images, text and audio. According to your problem statement, it can be applicable to images. If your problem statement is about the cloning of the voice, then it's about the audio. And if your problem statement is about the copy the content of as it is from some legal document, then there is a text, like the copy of the signature, right? Resemble the training data, real. Training data first be resembled over the discriminator, means discriminator has to train for the first time with the real data, such that it can make the predictions in terms of real and fake. Goal is to produce samples that are distinguished from the real data. Okay? We have to provide the samples from the generative model such that my discriminator will not distinguish that which one is the real and which one is the fake. That is the task of generative model. Okay? First neural network. Now what the discriminator will do, discriminator try to distinguish between real and generated images. As I told you, it is a basic neural network, right? It is just feed training data, train itself, learn the features and predicting the output in terms of real and fake. Simple. Second, third, also train with generated samples from the generator. So first train with real images. Second, after training with real images, it has to train with the samples created by the generator. Few samples. In our task, we have to do some sample about 100. Okay? Some 100 samples will be generated by the generator and it will go towards the discriminator, and again my discriminator will train with sample images generated by the generator. Why? Because we have to learn something from the discriminator. Okay, discriminator can only give me the power such that I can improve, right? So some task, some work I have to do and give to the discriminator such that that discriminator can provide me the feedback. That's why some sample images which are pertaining to the real images I will create and give to the discriminator. But these suppose image is cat. Okay? My task is to say that the giving image is cat or not. Okay? Means cat or not. If the cat, then say yes, otherwise no, with a probability. By including some random noise, I am creating something. Now generator have pre-visualized that something pixels I have to maintain over there such that some resemblance to the cat should be there. So I generated some samples, 100 samples I am generated, but these are not the real cat, something like dog, and I give to there. Now the discriminator provide me the probability that no, it is not a cat. With a low probability, you have to correct it. If this is a low probability feature over there, then it has to correct with the high learning rate. ठीक है, with a great momentum. अभी हम देखेंगे deep learning में concepts आगे. So it will take lot of epochs to train itself. कि एक या दो epoch में नहीं होगा. 12,000, 20,000 epochs you have to generate. That's why it is takes lot of time. After training the model with so many epochs, your generator will be able to produce the image which is something like cat. ठीक है? Now the training process. Training process says adversarial game between the generator and the discriminator. It is a game. GAN says that there is a game is going on between generator and discriminator, just like game is in our workplace. There are two employees which are fighting for the same promotion seat. It is very ordinary, right? Then what is the game between these two? They have to healthy competition, make a healthy competition. They have to learn from each other. Like suppose if I am a heavy competition with her in the same organization, okay, I have to learn something from his knowledge, her knowledge, that uh, what is the you can say her technique to solve a particular research problem. Okay, so there is some research problem, rough made by me, and I will come to her. Okay, I will go to her and ask her to suggest something over there. Now she can contribute with her knowledge. Like this problem statement is not there, you have to write this one, this one, this one. Like you can refer this one, this one, this one. She is very good in helping others. Now she will tell me so many things to me, and I will update the things according to her suggestion. Once a suggestion is incorporated, my research proposal will get very, very good. Now I will give the tough competition over there. So learning from her and giving again competition to her to fool herself, to fool her, right? So generator aims to produce sample that fool the discriminator. Clear? कैसे मैंने इनको fool किया? ठीक है. The discriminator tries to improve its ability to distinguish between the real and generator data. Like the same way, it has provided some outputs and feedbacks to the generator. But simultaneously, what the basic neural network do? If the discriminator predict the false output, the loss will be higher for the discriminator itself, right? If the loss is higher for the discriminator, then it has to train again with getting more features to its training data. So now again train will be there. Once a training will be there, it has to adapt itself. So basically these two are in the competition, right? For example, in progress, जैसे कि इन्होंने मेरी मदद की मेरी रिसर्च प्रपोजल को अच्छा बनाने के लिए, right? Now for the second time, I am again incorporating all of her suggestions, and again second time I will go to her to take her output. Now she says that your research proposal is very, very good. Okay, but it is fake, means copy pasting from someone else. Now from some after analysis, she get to know that no, this is a research proposal which is a fake one. So now she will adapt itself. She will learn from her mistake, right? For the next time. Such that if I will go to the research proposal with a fake outcomes, she will get to notify that no, your research proposal is not up to the level, it is a fake. So these are also, this neural network is also able to improve itself, and this one also able to improve itself. So both are in competition one by one. Depends upon which loss is higher. When the loss is higher for this, the training will be done over here. When the loss is higher for this, the training will be done over there. Okay. Converges to a point. Basically, I will not any relation with the discriminator loss over there, because my aim is to generate the fake images only. And once my model is able to analyze my image as a real, just like she says that my research proposal is good, then मेरा काम हो गया. उसके बाद वो अपने आप को improve करने के लिए क्या करती हैं? I doesn't matter. This is not my cup of tea. My only thing is my research proposal will be accepted by her. The same thing happened over there. Converges to a point means model succeed when the images generated by the generator is labeled as real by the discriminator. Then we can say my model is succeed. Now the domains. These are only the rough knowledge about the GANs. But what are the applications area? The first one is the image synthesis. Image synthesis means nothing but the image transformation. like the emojis you are going to create with the use of your faces, image synthesis. Also, in our mobile phones, there are so many features over there such that we can modify our lip features, eye sizes, cheek shadings, right? Brightness, contrast. So all the things this comes under the image synthesis. And nowadays we have used so many like face app. One is face app we are using. Face app is only used to enhance the features of your face, and you can just enhance the features of your face in an image and you can align in any profile picture. Text generation. Text generation means suppose I am writing one text. The color is red, the fragment is sweet, okay, the shape is round, and your model is able to generate one image. Okay, so text to image generation, or you can say text generation also. When there is an image and I will label the image with some values. Values means some text. Like one, there is a sunflower. Okay, the sunflower having some features like shape, color, so many things. According to the features, it will analyze and text will be generated. Like the poem, the chat GPT does the same. Video generation. From the video generation from the image, in the subsequent way we are going to merge, the video will be generated, right? But this video are nothing but the fake images generation. From the fake images I make some animated video, right? Your animation pictures is nothing but again the example of video generation, like Bahubali picture. Generating realistic images. Realistic images, like you can't differentiate between the fake and real one. Creating deep fakes. From deep fakes is another example of Rashmika and Alia Bhatt controversy. It is using by the deep fakes. Then enhancing low resolution images. So this last one domain is the research perspective. Okay, last one domain is from the research perspective, because there are so many images which are in the low resolution and they can convert it into the high resolution in order to extract more features. The first one is the cyber security. Like some crime scene is over there, some low resolution image is there due to some light quality. Now you can enhance the pixels of there and resolution is getting higher from the GAN model. Second one, medical imaging. X-ray, ultrasound images are very blurred, right? If you doing the ultrasound of your stomach, there are so many gases and so many things inside over there which can't be recognized by simple human eye. So by using this low resolution images, you can convert it into the high one by depicting some noises, just you can see in our second slide, right? And from this high resolution image, you can extract the features in more clearly. Third one, satellite images. Satellite images are also very blurred. Okay? Again, you have to convert into very high resolution image in order to analyze it. So basic image processing will not do in very accurate way. So you have to generate one GAN model such that it can enhance the pixel quality of your image. So last one is very important, enhancing low resolution images for your research perspective point of view. So why the GAN was developed? The first reason is in the machine learning and basic deep learning model, not the machine learning, in the deep learning model basic, once there is an image, suppose a cat, right? There is a cat over there. This is a cat. Now you are feeding this image to the basic neural network model. Now neural network will be able to predict that it is a cat image. Simple basic neural network. Now you are going to append some noise over there. Okay? But this noise can't be fetched by your deep learning model. Your model is still able to classify it is a cat. By impending some noise, I have a cat which having three eyes. Again, your neural network is able to classify, yes, it is a cat. So this is a disadvantage of, or you can say some limitation of basic neural network model, such that inspect the noise is there in your image, your deep learning model is can't able to recognize it, such that some security problems is sustaining with the deep learning models, like channel में some noise हो जाता है, images में कुछ लोग noise add कर देते हैं, right? Still model is able to identify the accurate values, but in currently it is not accurate properly. Now this GAN model can be understood like a banking system. So this is your bank, this is a thief, and this is the police inspector. Now what the thief is doing, if you have seen a movie Catch Me If You Can, okay, Catch Me If You Can, the movie is saying that hero is able to duplicate the notes of the currency, okay, by using some patterns over there, by learning some you can say ink and some styling techniques of the writing over the note. So like the thief is there. Now the thief is able to produce one note, $100 of note is there over there, and it is going to the bank system, okay, in order to deposit in or something another account. Now there is an inspector over there which are able to identify that which one is the real and which one is the fake. For the first time, the inspector is able to identify, no, the note deposit by you is not real, but it is a only story. So there is no any you can say any event will be generated by the discriminator. Thus, he and she can only give the feedback to the thief that this note is not a real one. You have to correct it. Now again, thief will go. Thief will train itself by learning more features, more ink styling and whatever it is. Again going to the same bank system with the updation of the note. Now the bank is receive the note. So that this conversion points we can say my GAN model is successful, because bank is accepting the currency and my discriminator is successfully fooled by this thief. So hopefully you are understand the concept of GAN. Now these are the GAN samples generated by the model, and these are the fake images. All are fake images. You can see the beauty and clarity and the pixel resolution. How much it is clear. Another example of the GAN. Suppose you have a restaurant. You open a restaurant, and in the display, there is a one display inside and outside of your restaurant, in which you want to display the images of your food items, right? Now there are one solution. First solution is you are taking the manual picture and just wave stick over there, ठीक है? Normally traditional लोग ऐसा करते हैं. Second one is you can generate some samples which is real. Obviously you are making a food and capture the picture and just display one by one according to a certain time limit in a repetition fashion. But you want to do some more intuitive manner, innovative manner. Then what you will do, you will ask to one a developer that generate a images in a unique way in a certain model, that your image should look beautiful, as well as it will not repeat for certain 1 month suppose, and one food item suppose dosa having 50 pictures, 1 2 3 and so many 50. If you are doing this in a manual way, it will take lots of time. It is possible, but it will take lots of time. But your GAN model will able to do it within a few minutes. All are fake images, but beautiful dosa pictures in a unique way will comes into account and display over there. Okay. So this is how you can utilize these applications over your companies, or you can say in your restaurant. Now, generator, there is a noise, Gaussian noise you have created. You can see this is the phase which are pertaining to that, but this is not the any similarity between them pertaining to generate from these images somehow. Now the celebrated faces dataset, which is the real databases are labeled as real, and this generator is generating the images by using some noise and some predefined features which is mentioned by the user itself and labeled as a fake. Now these two, label as a real and fake, will comes into the discriminator model. Now what the discriminator will do, I told you, real and fake. Okay, once it is real and fake, two losses are created, discriminator loss and generator loss. And I told you there is a joint probability, which is a combination of both losses, and again these losses are back propagation to the generator and to the discriminator to adapt and enhance the activity for the future perspective. Now the discriminator is a supervised learning approach. Why supervised? First reason is my training data is labeled, right? As well as my training data is available. I am not starting from the scratch. Training data is available, just I am putting inside my dataset variable. Provide feedbacks to the generator means there is a back propagation. So for the initial training, point number 1, it is only feed forward network, right? For the second one, it is again the feed forward network. But for the third one, when it is distributing the loss to the generator, it is a back propagation network. So one model can train in multiple ways, but with a different multi perceptrons. The first one is feed forward, and the last one is back propagation. Back propagation is needed such that your generator will able to adapt itself with a pertaining losses. Now the generator is an unsupervised learning approach. As I told you, there is no relation between the generator images as well as the your discriminator images. Generator has to do from the noise, means it can start from the scratch. That's why it will take so many epochs. Once the feedback is received by the generator from the discriminator, then it can train itself by learning. Otherwise, there is no any training data available with the generator. So generator is an unsupervised learning approach. It is also a neural network that has a hidden layer, activation and loss function. So in the hands-on, you can see if we find the generator and the discriminator strategies in order to implement that, both having the hidden layers as well as some activation functions, because these are nothing but the neural networks. Okay. It's aimed to generate the fake images based on the feedback and make the discriminator fool that it cannot predict the image that it is a fake one. And when the discriminator is made fool by the generator, my model is get succeed. Now some mathematical term. So this is a latent random variable. Latent random variable is nothing but my noise. Okay? It is denoted as Z over there. Z. Generator is denoted by G, and you can see there is a sample. This sample is nothing but this one. This sample. So when this noise is going to the generator model, one sample is created in terms of the image. This image is represented by GZ. Means generator model G under the parameter is noise. Real world images means it is a training data and it is denoted by X. So when it is going towards the discriminator, then discriminator and the parameter is real time images, that is X. So DX and GZ. Now what the discriminator will do, termed as a real and fake. Okay? Now you can see in my previous example, after generation of the images labeled as a fake, this fake is nothing but g of parameter z is again putting as an input to the discriminator. So when it is putting inside the discriminator under the parameter g and z, same thing I am doing. So these are nothing but the fake images generated by the generator. When it is minimum, there is an advantage for the generative to learn more features from the discriminator. On the other hand, your discriminator has to maximize the loss such that it can predict the things in a accurate fashion. Equal to expected value of real data. E for expected value of P data is the real data of X log dx. So I am taking log because we are talking about the cross entropy method. In the cross entropy, all of the losses have to be fitted in terms of the log itself. So log of dx plus expected value of noisy data 1 minus d and gx. Okay, so you can say if it is a maximize, its value will be 1, 1 minus 1 0, then it will be going to cancel. So that's why the generator wants to minimize the loss, because if it is maximized, what is the maximum value? 1. If you putting 1 over there, it will be 0. So that's why it tries to minimize the loss and your discriminator tries to maximize the loss. इसमें किसी को problem? Your whole GAN model is based on this function in order to calculate the loss. But there is a beauty in the deep learning that the model is also inbuilt, right? So once you are compile your combined model, like the discriminator with the fake images, you have to pass the parameter binary cross entropy. You are not going to code this whole formula. Just you have to pass the function name, that is binary cross entropy, and take the value as a parameter of accuracy loss for the discriminator, accuracy loss for the generator. But internally the work is going like that. More clear diagram. Again, latent space is nothing but the noise generator, generated samples, real images under the discriminator. These are the loss function combined probability, and according to the probability it has to send the losses. Should I proceed? Now same picture but with a more clarity of the neural network. Random noise, then you have to make a model in terms of the hidden layer, input layer, output layer, some activation functions. Now sampling and real faces. Here nothing is required because the training data is directly fed over the discriminator. Again the discriminator you can see over the neural networks. Hidden layer, activation functions, output layer, input layer, and some weight management. Now the generator and real face, and at the end it will depict it as real or fake. Now types of GAN. We also see the applications of GAN, right? Now the types of GAN: DC GAN, deep convolution GAN, in which your max pooling layer, like the max pooling in the deep neural network, simple CNN model, has some model over there, right? Max pooling. So max pooling is missing over there in the deep convolution GANs. That is the only difference. Now the conditional GAN. Conditional GAN, as the name indicates, there should be one condition associated. Like same ways, if I am predicting that it is a cat only, so you have to term yes or no that it is a cat or not. So this is my condition, that it is a cat or not. Unconditional GANs. Unconditional GANs means I'm not restricting over the cat over there. but using of some pattern I am predicting yes or no. Okay. Now least square GAN. Least square is very simple. There is one least square entropy functions over there. So you can utilize that least square over there, that nothing is different. Now auxiliary classifier. Auxiliary classifier is very good term because along with the loss functions, this auxiliary classifier provides you that which pixel levels you want to increase in order to train your model in a good way. Like if we are providing the feedback to our students, so we can say that okay, your theory is good, but somehow you have to work with your practical. So along with the performance, we have to provide the attribute factors also. Like your performance is good, your theory is good, but somehow you have to work over the coding perspective. Means in the practical sessions, you have to work harder. So like the same way, along with the probabilities, they are providing the attribute factors, that which pixel value you want to increase. You have to increase. Dual video discriminator GAN. Dual video means some video generation by the GANs, right? And this dual video is nothing but if I'm saying like my name is Nidhi and my fake video is generated over there, and the same fake video is again saying the same thing, my name is Nidhi, but the face is different, body is different, all of the architecture is different. So video is there, dual video, but with a different architecture. SR GAN, super resolution GAN. Super resolution is nothing but enhancing the resolution, means pixel quality of your images and the videos. Cycle GAN. In the cycle GAN, when there is a cycle over there, means cycle means what? There is a back propagation, right? Now the generator also has to tell to the discriminator that in order to provide the feedback, what the things you have to maintain in the feedback message. Like somehow your cycle GAN and auxiliary GANs are interconnected. But this is fixed. Cycle GAN is modifying the content, that which feature I want to improve myself. Okay. Suppose I am asking that which feature I have to enhance in myself. There is a one-way communication that at the last you will give the feedback. Right? This is the one way. You can say auxiliary one. But in the cycle, in the first way, I have to ask you that which feature I have to enhance. And at the last of the session, you will give the feedback कि हमने इनको ये feature बताया था, इस feature में इन्होंने ये काम किया है. ठीक है? Information GAN. Information GAN is again taking the features in a more elaborative way, like the intensity. So intensity means, suppose we have draw 5. ठीक है? 5 digit. It might possible that my training images, some images have like this, some images will be like this, some images will be like this. So intensity is different, right? So your model is using the information gain such that within the same pattern, it will work with the different intensity value. Like in our previous session, I told you one example of the watermelon fruit. Taste is sweet, shape is oval, and the color is red. Okay? One of you give the same answer that Goa is the another answer. What is the drawback? What is the difference? Only the intensity value. Right? So for the GAN, it will feed you all the intensity values and taking as the same parameter. Means it will take this one and considered as 5. This will take this one considered as 5, again 5, again 5, again 5. But for your nearby, it will be different. If it is a watermelon, then it will be as a go. Right? Now you tell me which one is the real. Again, left side is real. Okay. Any other answers? Right side. Can't see. अच्छा. दोनों. First one. First one. क्या? Hmm. 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 So she wants to say that here all of the intensity values are good, right? But here is not. In my first image, the intensities are, the first one is low and the second one is high. So that's why your GAN models try to fool you. You can't differentiate between the real and the generated one. Actually, this image is taken from a different number of epochs, some middle epoch. So once the epoch is get a higher and higher, more quality images you able to generate. So I am taking this image in a middle of epoch. So you can see it is trying to analyze only. Analyze. But it's not able to, because further epochs it can able to analyze that it is a 8 or something. So in our today's hands-on, we will implement this one example also. So that is my random noise generator and we will set minutes data set. Okay. So this is a minutes data set which is generated by, this is a generator by using some noise, and that is a real one that you have to load from the sklearn library. Okay. Once it is loaded, it will go into the discriminator. Now the discriminator will able to identify it is a real or fake. So before jump to the hands-on, first you have to understand about the code models. Step number 1, we have to define a problem, that which type of problem I have to able to solve. It is a text problem, it is a video problem, or it is audio problem, it is an image problem. Second, the architecture of GAN. There are so many architecture I have depicted to you. Okay. So DC GAN I have to use over there. First one. Train discriminator on real data set. Point number 1. Train with the real images. In train with the real images, a forward path only, no back propagation, no feedback. Second one, only contains real images. Fake images in the second step. The first one is real images and then will fake images. Classify both real and fake data such that the first training data, whatever it is labeled as real 1. The second, the fake samples, point number second is labeled as 0. Discriminator loss helps improve its performance and penalize it when it is misclassified. So when these two trainings are done, your model is able to predict discriminator. Discriminator is able to predict that which one is the real and which one is the sample. If it is incorrectly classified, then it will penalize itself. And again training will be done by adapting the weights, right? Weights of the discriminators are updated through the loss. Now train the generator. For the generation of the training, fake inputs for the generator noise first. Second, generate some fake outputs, min samples. Tries to transform into the meaningful data. That third point is done by the user itself. मॉडल नहीं करेगा, वो आपको कोड करना पड़ेगा उसका, ठीक है. Tries to transform it into the meaningful data because you know about which you are going to predict, cat images, flower images, or something else, celebrity images. So according to their pixel intensity you have to fit something in your generative model coding. So something how meaningful data you have to generate. Predict generator output from the discriminator as original or fake. So once a point number 2 is there, sample images is created. Now the prediction will be made. Calculate the discriminator loss, joint probability. Perform the backpropagation, feedback. Use gradients to update generate weights. Gradients, there is an alpha parameter inside my deep learning model that we will see, that is used to calculate the gradients in order to update the weight parameters. Now train discriminator on fake data. Actually this is step number 5 and step number 1 are merged somehow. This fake samples. So I'm just elaborating the step number 5. Sample will pass to the discriminator and provide feedback to the generator again. Then train generator with the output of the discriminator. अब point number 5 में एक more add on है. The thing is we have to generate the samples 2 times. In the step number 1 for training the discriminator and the step number 5. And again I have to take the feedback from the discriminator, because I have to adapt myself, right? So 2 times of training samples I have to generate with a different number of epochs. This is a hard processing. Train generator with the output of the discriminator. Same thing. 2 times samples will be created, 2 times feedback I have to take from the discriminator. Again I have to adapt itself, means the generator will train along with the output of the discriminator and feed it towards the discriminator. So ये process आपको continue चलता रहता है, ठीक है, until the convergence point is your discriminator is able to analyze or predict that your sample image is real one. Now implementation process के लिए first one is you have to import all the libraries. Second one is generating the data set. Data preparation in which you have to perform some pre-processing. SVM में भी किया था हमने some pre-processing. Fourth, define the function of generator and the discriminator. First function I have to describe, not the model, only the function. Fifth one, we have to create the random noise. There is some function to create the random noise you can create, and create the image means sample from this random noise. Sixth one, setting the parameters like defining epoch, batch size and sample size. Define the function of generating sample images. As I told you, we have to generate the sample images in different timings such that it can train itself in a more accurate way. So again sample images मुझे generate करनी पड़ेगी. Train discriminator then train generator. You can see only the function is defined and here the main training is going on. Last one we will see that what clarity of images is created by the generator, means fake images I have to create. So that is the introduction about the data set. This is the data set of the MNIST in which the dimension is 28 cross 28. Okay, 2-dimension images it has and the color is RGB. So I have to flatten my image to 1 dimension, right? Digits is only from 0 to 9 in a grayscale format. Now our aim is to train the discriminator model with a MNIST data set and to generate the fake images such that your discriminator will be able to label your fake images as the real one. That is the only task I have to do. How many samples are there? 60,000. Okay, 60,000 samples we have. So this is the collab one link. You can see, otherwise वो PDF share कर दीजिए. You can start your system.